Guys, so today I'm going to show you how to make a protein using amino acids chain. So I'll give you the link to the PDF file where you can find these models in the description below. But here, what I started with is just taping the A chain together with the other E chain, and this is the B chain, and I basically just taped it together at the gray spot and forming a long chain from residue 1 to residue 13 and 13. So I'm going to show you what to do next. So now the next step after you form your peptide bonds and chain, the protein is going to form an alpha helix, which means that some sections of the amino acid chain will curl and form alpha helixes due to the hydrogen bond between the NH and the CO groups. And the helix regions on the model are marked on the chain with the darker shades of green and blue. So just look at residue 1 here and residue 5. We're going to try and match up the residue 1 at the COO end and match it up with the NH part like so. Alright, so now I'm going to tape all of those parts together. So as you can see here, I've taped up the parts. So keep creating the hydrogen bonds until you reach the end of the darker colored area, and when you reach residue 66, make sure that the green half is outside of the helix. Keep rolling, rolling. Now on the other side, you are going to create another alpha helix starting with the 17 residue and the 21. Keep creating these hydrogen bonds until you reach the end of the dark color. So now, with the chain B, starting with residue 7 and 11, form a hydrogen bond and keep creating the alpha helix until you reach the end of the darker color. So I will show you now. So far your molecule is gonna look like this. And now the next step is gonna be the turns. So some amino acids give a turn to the chain, and the turns are marked on the chain B, the paper model with the white dashed lines, so these ones right here. So just fold along those lines. It looks something like this now. What you needed to do was to fold outwards on the white dashed lines to create the turns. You can secure the fold with the tape. Now we are going to form the disulfide bridges. The structure of insulin is stabilized by 3 disulfide bridges. A disulfur bridge is formed when a sulfur atom is from the residue cysteine forms a single covalent bond with a sulfur atom from a second cysteine. So the first disulfide bridge connects 2 cysteine of chain A to form the bridge and connect the green tabs like so. So here is the disulfide bond between the two, and your molecule should look somewhat like this now. Alright. You might be wondering what the yellow tab is. Well, the second and third disulfide bridges represented by the orange and yellow tabs are formed between chains A and chain B, but we'll get to that. So now we will connect the yellow tab, matching their shape while making sure that the colored sides are facing the same way. So I'm going to do that and then I'm going to show you. Half should be attached like so, and we're again matching their shape while making sure the colored sides are facing the same way. Alright, now we're gonna connect the orange tab, matching their shape while making sure the color sides are facing the same way as well. So, this is the final product. This took me a lot of time and effort, but I finally figured it out, and that was your final step. So, do you see here, the orange part is gonna have to go on top of the orange part. So, the one underneath here is the orange side as well. You can see in this part. And when you tape up the yellow, it should also be the same, where yellow on top of yellow. Alright, and that is gonna be your sulfide bridges. And yeah, there you go. There you go. Now we have a beautifully made insulin ball. Cool, eh? Cool, 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 cool. Cool, 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 cool. Well, it's Anne, so peace out. Have a good day.